Right, welcome back to another session on the chess engine in C. And today my idea is to try and implement the same stuff that we have so far by using Raylib. And the reason why would be because it's gonna run natively and we'll be able to write SO files or DLLs like we did with the tic-tac-toe and Connect 4 games. And we'll be able to evaluate chess engines easier, like we'll be able to implement them easier and make them um, play against each other. And then we'll take the best one, put it in the web build, and then make it available on GitHub for everyone to play against it. So that would be the way I'm thinking about it. So what I'm gonna do now, I just added to my Nix Flake, I added Raylib as a dependency. So we should be able to just create the main file, or I'm gonna call it raylib.c maybe, and we'll have wasm.c and raylib.c. And let's try to just run the Raylib example. So I guess to build this thing, let's try to just use clang src slash raylib.c, and we might need to link with Raylib. So I think you have to say dash L Raylib, right? Or something like that. Oh, and it, yeah, a.out. And let's make it go into maybe dist slash Raylib. So we'll run dist Raylib and we should get a window. That's nice. So what should we do with this stuff now is try and copy paste from our chess.c, which is going to become probably like wasm.c, and then we'll have a common, yeah, why not, let's just rename it to wasm.c. So this is going to be the wasm build, right? We just need to change here the C path. We use wasm.c, and let's try to have this chess.c file that's gonna have the common stuff. So for instance, we're gonna have a chess.h file, right? If not defined chess.h, define chess.h, and then end if. So this is gonna be like a library that we'll be able to use from both the web build and from the Raylib build. Now that's my idea for it. Okay, so we might need this square, we'll need the flags, chessboard T. Not sure about the colors. So let's just copy with these things. We'll think about the colors. Maybe we want to, you know, be able to inject the theme for the chess thingies. Maybe it's gonna be maybe these are gonna be the default values, and we'll be able to change them at I don't know, startup or something. We'll see. But these are the default values. Okay, what else would we need in our chess.h file? Let's think about it. So obviously we'll need, would be interesting to have just a single board, like have it as a global variable, but at the same time, since it's like more of a library, we could also copy paste these functions, and yeah, like that's an idea. Pixel to square, square to pixel, these are just they depend on JS stuff, right? This one could also be a good function to have there. Print board could also be a good function, and then it's gonna be implemented for WASM and differently for Raylib. That's what I think here. Then this one with valid moves for a pawn and so on and so forth. These could be just implemented the same for both of them, getting the valid moves, right? So let's try to copy paste some of these functions. So I'm gonna take these ones. We'll have this chess.c, and I mean, I know it's already defined, but we'll just replace that. And then let's see inside of chess.h. So I would copy paste these ones, and obviously we need here a chess board t pointer board. So we don't have a global variable anymore, but no, we'll probably do have one, at least for WASM. So this one is a void. Okay, what else do we need? I said this one might be something WASM related, so I'm not gonna change it. These ones, again, I don't know. Right now, chess load fan. This one works. We could have it. Void function, chess board, t pointer board. But see here, at this point, we need, wait, I made a typo. So this is like a init fan or something, fan notation. And the idea here is that we need a string slice reference. But what I'm not sure is if I include here, include ds.h, right? What I'm curious is if I will be able to define these things and then have it like defined also here. You'll see what I mean in a second. But yeah, now we have a reference to string slice. But I mean, even if we didn't, we could have just used a struct like this, and then at some point, like this works, right? It doesn't care that it's not defined. And then when you include ds.h in the file that chess.h is also included, it will know that it refers to that symbol. But I think this is also fine. I mean, it should also be fine. I hope. We'll see. So this is the init function, being able to get a square, set a square, and yeah. I mean, maybe the only thing that's kind of meh is that you can make a invalid square, but I don't think I care that much about it. Like, it's gonna crash instantly if you try to use a wrong, like a out of bounds index. Like, that's a big mistake. So I'm gonna do an assert. Okay. What else do we need from wasm.c? Well, being able to print a board, that's obviously a good one. And this function is gonna be, oops, chess board, a pointer board. And this one is gonna be interesting because it's gonna be implemented differently for WASM and for Raylib. So we'll have two implementations. Okay, this one with the valid moves, I think it's kind of interesting. So I'm just gonna copy paste chess valid moves into chess.h. This one is gonna have the same implementation regardless of the platform, because I mean, come on, but it needs an access to the board. It needs the selected square, so which piece you want to move, and it's going to output this dynamic array pointer moves, and it's going to output all the moves that you can make from that square. Okay, perfect. Let's have this already have chess.c. So I'm going to include chess.h. Oops. Chess.h. Chess.h, and we need these functions implemented. So these ones are the only functions that are gonna be the same everywhere. So that's why I copy pasted only them. This one, print board, is gonna be implemented for each platform separately. Oh yeah. Okay, and oops, we have the definitions. So let's have a get function. Okay, this one needs to be dereferenced first, right? So we can access the board, and then we have a set, and this one also needs to be dereferenced. Okay, now we need the init function, which is just wasm.c. We had it somewhere here, and this one, it's like the fan notation. I mean, you know, it doesn't really matter. It's something like, if you have a P, it represents like a white pawn, and if it's uppercase it's white, if it's lowercase it's black. And then if we look at chess.h, you can see that it's like all the black pieces, all the black pawns, then a number represents like empty spaces, and slash represents a new line. So that's the idea here. I don't know what this stuff is, I just copy pasted it from Wikipedia, but you know, that's what I understood. Okay, so here it complains that chess square t, it doesn't have the board argument, so we can just pass it in. Yeah, I guess that just worked. And now we have an implementation for this one as well. All right. Okay. And the last one that we need is valid moves, which we can just copy paste as well, I think. Just 1 second, let me just delete these ones because we don't need them. So this one with load, we don't need it. Print board, we need print board. Valid moves, we need to just copy paste it. I guess I'm gonna cut and paste it. So just take this stuff. Okay, and we have a bunch of errors. Perfect. I mean, ds dynamic array pointer moves, and we can just send in the moves. Nice. And even get, it needs, oh, I also need to send a board. That's the problem with using global variables. If you need to change from global variables, it becomes, I mean, it's not annoying because you just send it as an argument, like, yeah, an argument, but you get the point. And now we need to refactor it. But it's pretty straightforward. Okay, now we need to do the same here. We need to add the board. We need to add this dynamic array pointer moves, and we need to add here board and moves. Same stuff for the bishop and yes, array pointer moves. Okay, and this one, set that, set this stuff. Okay, we need again, I guess the arguments are the same for all functions, so I can just copy paste them. But yeah, I need to send here the board and the moves. Okay, nice. Then we have the queen. And I think the last one was the king. So let's also update this one. Okay. Here we don't need it to be a reference. And here we need to just send the board and the moves. So I can just copy paste this everywhere. So vi parentheses space p. Oops. Nice. So now we have chess valid moves, and it's going to give us the valid moves for each piece that we click. So if we go back to this one, and here I was thinking, what if we just include chess.h? So we don't need these things anymore. And inside of wasm.h, what if we take all of this stuff, because it's kind of weird, and we bring it here, like that somehow. Right, so I think something like this. So you can see that here we define all the, no stdlib, all of this stuff. wasm.h though contains only, I think it should only contain references to the JS functions. I don't think it should have anything else. I think it should be like a standalone, and if we need to copy paste it somewhere else, we can just copy paste the JS functions. I think that's how it's supposed to work, or at least how I imagine it. Then chess.h, so this could even be like that, but then chess.h, it includes ds.h, right? Because it needs references to dynamic array, it needs references to slice, and so on. So we have to do all of these defines, I think. And because we also need to use SB or string builder and string slices and so on, we need to define an implementation for string builder append, but we need to use JS format instead of VSN printf. So I think it's fine to keep it here. Because WASM, like wasm.h doesn't really care. Like, I don't think it should care about ds.h. That's what I think. And in index.ds, we have this stuff, which, yeah, I think it shouldn't care about. Yeah, I think it's fine. I don't think it should care about ds.h. I think they should be separate. Okay. Anyway. So print board, if we go back to chess.h, it's the function that I said it should be implemented differently depending on where you use it. Okay, so here we have our board. And I think these ones, these ones are interesting. But yeah, whatever. These ones are fine here, like it makes sense. So print board, okay. We do that. Chess apply move. Clearly this is gonna need chess board the pointer board. Here to pass the board, here to pass the board. Wait, what? Oh, here we need to pass the board, okay. So this applies a move. Yeah, whatever, doesn't really matter. So give this the reference to board, and I rename this one to init fan. I think it makes maybe more sense. Oh, this one wants a reference, yeah. I mean, usually I like to have it as a reference, but okay. Chess apply move, it needs the board, obviously. Chess valid moves, and I think we need to give it reference to moves. Okay, so it looks like there are no errors. Interesting. That's pretty cool. Right. And I would still maybe put the variables first because why not? So yeah. But at this point, let's try to just move all of these. So obviously we can just npm run build. Hopefully it's working. Although I'm not sure, do I need? I'm pretty sure I need to add chess.c as a dependency in webpack. Why did it work? src/chess.c. Like you think I need that as a and yeah, here I guess you see the error that inside chess.c we include chess.h, right? But we don't have those defines. Interesting. So what you're telling me that if I just build this it works? I mean, it doesn't make sense, but I guess what I'm gonna try to do instead, yeah, so obviously it couldn't work because we don't have these functions. So we need chess.c. What we could do here is, if we check WASM C, we could just define all of these in here. So we could say something like -d no stdlib, right? We could say -d this, -d that. Right, that's the same thing as defining them in the file. How can do I need to put an equal? I mean, the warnings, I don't really care about the warnings, right? But what's this duplicate symbol? Oh. Yeah. That's kind of the annoying part. Because problem is we already define the implementation here. Okay, so maybe maybe the problem is I don't want to have like implementation in here, or at least for stdlib. So here maybe I want to have just like this. You specify which allocator you want to use, but you are not forced to actually use an implementation. I think that's the right way to do it. Because if you're forced to also generate implementation, then that's kind of bad, because you cannot really have multiple files. So yeah, maybe we want to force just that, and then the implementation you specify it where you need it. So then inside of wasm.c, right, you can specify some things like that. Let's wait a second. So maybe inside of chess.c we need to specify that we want DA and SB implementation. Maybe chess.c is gonna contain the implementation for dynamic array and string builder. Why not? Because chess.c is gonna be the main like library. and then inside of wasm.c we'll say okay, but we want the init capacity to be 8, right? We want to use the list allocator, and we also want to include the allocator implementation. And what if we take these defines actually and we move these defines in Webpack? So we say, okay, build all the files but with no stdlib and with the list allocator. And maybe no terminal colors or something. I don't know why I don't want terminal colors, but whatever. And maybe even, oops, maybe even init capacity should be 8 here. And then we want the list allocator implementation to be included in this WASM file. Maybe that's a better way to do it, a better approach. Here it complains about the exit function. I don't really care about exit, honestly, so maybe I want to just remove it. Maybe that's not even important. So right now we don't have any warnings, that's fine. And if we refresh the page, it still works. I mean, you know, it's yeah, it still works. That's what I meant to say. I think that's how I want to do it. So it's like chess.c, it also contains the code for dynamic arrays and string slices / string builder. And then wasm.c contains the code for the list allocator, right? Contains the code for the list allocator. And then in Webpack, we have a define that we don't want to include stdlib anywhere for ds.h. We want to use list allocator, but this one, list allocator, it's just for this define. ds allocator, ds init whatever, right? It's just defines for convenience, because we can work even without these defines. We don't need them, but it's like more convenient to switch between allocators. No terminal colors, whatever. I don't want to use terminal colors. And the initial capacity for an array, it's gonna be 8. Because I don't know, I made it 8, but whatever. I think that's pretty cool. And now the code is much smaller for this one. So let's try to make this printing work for Raylib as well. So maybe I want a make file for Raylib. Make file. I don't know. I mean, we already have a way to build Raylib. So this Raylib. So I will do the make file on my own. But yeah, we have init window. Let's make it 800 by 800. Let's call it chess. No, index HTML chess engine. So we basically have the init here. So if we look at wasm.c, we could do something like we can just copy paste this stuff. We don't need to clear canvas, we don't need allocator, we don't need, the fuck is this? Dynamic array init allocator. We need that, so we need to include chess.h, right? We need that. we need the reference to board, so, and it's gonna be global. And then we call to print board, and I think print board should be here. Print board, and then close window. Obviously we need more stuff, but for now let's just do print board. So print board, we'll copy paste this stuff. We don't have width and height, but we can define width 800, height 800. Maybe we can even say screen width and screen height. Right. And I guess just replace them. Screen width, screen height. Okay, then we do the computations, whatever, and here we have JS fill rect, JS draw texture. So we want a function that draws a rectangle in Raylib. Well, I guess where is raylib.h? Rect. Fill. Maybe it has fill. Draw rect. Draw rectangle. Draw color filled rectangle. Nice. So that's, pretty straightforward. So we call to draw rectangle, file pixel x, rank pixel, cell width, cell height, and square color, but I don't know how can we switch between them. So what's a color? I guess the color is RGBA. RGBA. And this one is just the RGB. Just the RGB. Int square color alpha is maybe square color. We shift by 8, and then we maybe just or by 0xff. So we add an alpha and color square, maybe just color. Can I just cast this thing? Do we have some functions that involve color and integer? I don't know. Color. I mean, these ones are the only ones that involve color and something, so I don't think so. Okay. Then let's do just we'll have R, which is basically square color and 0xff0000. G, which is square color ff00 RGB square color f and alpha, which is going to be 0xff. I think that looks fine. And here we have color. Perfect. So let's see if at least we have the squares working. So I need to add src Raylib and src chess.c. I don't think I need any defines, so it should work. Probably made a typo somewhere with the colors. So we have RGB, red, green, blue. What the fuck? Wait, am I... RGB. What the fuck? RGBA. Wait a second. Oh, you know what? I think... No, I mean, it should be good. What the fuck is wrong? Why was it so blue? RGB. The fuck? I mean, I could... No. Bro, what? What the actual fuck? Shit, what the fuck? I'm so confused, but it's pretty funny that it's so blue. I mean, it should be white and brownish, like here. The fuck, why is it blue? Square color, it's right to use bitwise and, right? Am I not stupid? And then 0xff0000, it's different than just ff. Okay, I mean, maybe I'm just stupid. Let's try to do something like 0x 7c. Like what? And the last one is 60. I just want to see if the colors are right like this. Yeah, that's the right color. Then why is this not working? What the fuck? Well, you know what? Here you can actually use printf. Nice. I'm like so confused. So F4A9. Yeah, that's true. F4A9. F4A9. That's good. But what if I put 00 in here? Ew. 7C00. Ew. I forgot about something. I forgot about a little thingy here, which is shifting the result then. Oh, fuck. What? It's not that. 7c d3. Yeah, 7c d3. And what if I shift it like that? Oh, what? Wait, what the fuck? Okay, what? No, this makes me really... Oh, I get it. Okay, this one needs to be shifted by 16. And this one basically by 0, but you know. I mean... it looks... Oh! I'm sorry. I'm sorry, I made it nice. But it looks pretty cool. Okay. So, now the goal would be to draw the textures. Can Raylib draw texture? Texture. Draw image, draw texture, draw texture. That's interesting. Draw texture 2D. Draw a texture 2D. Now the question is, like, okay, we can just file pixel, rank pixel, cell width, cell height. Interesting. Maybe we want some kind of scaling. We'll see if we want to use X with extended parameters. Maybe we want to have a scale. We'll see. But for the tint, we want color. I know there is a like white. I don't want any tint. Oh, it's just white. Okay, so how can we get a texture? So that's a good point. How can we actually get a texture? Let's check that draw texture thingy. Load texture. Whoa. We can just simply load the texture from an image, from a file name. Texture 2D. It has a width and a height, so it's gonna be pretty straightforward to get the scale. What kind of sucks is, do I want to do this every time? That sounds crazy. So we might want to first load all the textures and then have like a hash map. Oh no, hash map. Oh no, hash map. Okay, fair enough. Let's try to use hash map because we do have hash maps in ds.h. I just don't usually use them because I don't really like it. So the question is, do we really need a hash map? I don't know, but we'll for sure need this function. chess piece texture path. This is like the assets that we have. So chess piece texture path. And how can we have a load texture cached? Like I want to cache the texture. So chess.h, we definitely need hash map. Wait, what? Hash map. What the fuck? Hash map insert. So we need to define hash map implementation. I guess, I mean, we don't even need to care about. Okay. So ds hash map. Let's say we'll have a hash map called assets, or maybe textures. Maybe textures. Yeah, I mean, the only thing that I maybe guess it's kind of meh with the hash map is you need a lot of code. You need a hashing function, you need a compare function, but it's not that bad, I guess. So we could just have a string hash, string compare, and we also need a max capacity. Let's define it. Okay, so we have the string hash function and the string compare function, and now we can just init the hash map. Obviously we need to init the hash map here. We need to define the string, and it's gonna be textures. I mean, sure, we can have a defer and then int result equal 1, 0, just to have it. Okay, and then we have to insert some key values, which is the part that kind of sucks. Okay, so let's have a function just like load texture. It's gonna be static. Load texture cached, right? And it's gonna take in the file name, and we are first gonna check if we have. So how can we do that? Something like this maybe. So we'll look for the key which is file name, hashmap kv. This one is yeah, it's void pointer. Okay, so I need to cast it to void pointer. The value is null, and then we are trying to take from textures. Kv could not get from hashmap, but could not get from hashmap because the item is not there, or fail to find item in hashmap. Do we have a has? Oh shit, we don't have a have. We don't have a contains function? What the fuck? I mean, I wouldn't say that's an error though. I wouldn't say if you don't find something that's an error. It should only be an error if you get an error. Like this, I don't think it should be an error. Maybe I want to make it like get or default. Right? Maybe I want to have like a get or default. And like get or default maybe. And then we'll implement get or default. Sorry, I had a humongous sneeze. Okay, so get or default. If not found, then kv value is default. And then in here, maybe we can just call get or default. Get or default map kv null. And obviously if this thing is not equal to this okay, then we error out, right? And maybe in here kv arrow value is equal to null, then we are going to crash like this. And then get or default is the one that I'm gonna use. Right, like get or default. Default is null. Let's expect. And I think expect wants a message. Failed to get a value. Actually, I mean it's unreachable, but oops. This is unreachable. So this one should always work. It's kind of unreachable to not work. Anyway. Okay, so we get the kv, and then if kv.value is not null, then we can just return star texture to the pointer kv.value. So I'm gonna store as a we'll see. Otherwise I'm gonna do load texture, file name, and this one returns a texture, so texture to the texture and into GPU memory. we have to think about this one. So what I want to do at this point, so I want to save it inside of the value. So I would like to say something like kv.value is equal to ds malloc, and here I'm gonna use textures allocated. Can I need ds include ds.h, right? Shit. But why don't I have a ds malloc? Are you stupid? Oh, it's because it needs also size. But textures is a hash map and it has an allocator. Okay, perfect. So it has allocator. But why textures allocator? Yeah, so it does have the allocator. Perfect. So we are allocating, and now let's think. Size of texture to D. Should I let me just double check. Insert. So if I do insert, how does insert work? It does a, so it's gonna do a mem copy. Okay, I don't think I need to allocate anything. So I can just say is equal to texture like this. But I need to somehow convert. Yeah, I cannot do that. Either I allocate this kind of size and then I mem copy it, which I think is the only way to do it. So inside of value I should just mem copy this, mem copy kv.value from texture size of texture to D. And I think that's what I need to do, and then return texture. And it's not going to work with the first part. So here at this point I need to do a ds mem copy as well into texture from kv.value size of texture to D, and then return texture as well. Right, so inside of this kv.value I'm storing the texture itself, like a copy. It's not an address. So the value that's inside of this dot value, it's actually the structure. I think that's how it can work. And then load texture cached texture, and then we are just drawing the texture. So here I need to take the name, and now this is interesting. Because it depends can I just go with assets slash, or maybe inside of ds.h, where I have the IO functions, can I also have a function for joining this hdef int, or maybe this result path join const char pointer path const char pointer path 2, or maybe like it's path 1 path 2, and here char pointer path or something, I don't know. Would it make sense to implement it? I mean, it's kind of meh. I'm just gonna hard code it. So let's put here assets. The only thing I guess would be annoying is multiple what? Right, because I define DA multiple times. Okay, so then I just put it here for now. Yeah, and failed to open file because we are not inside of dist, right? But if I run it from in here, it works. That's pretty nice. Okay, that's cool. Again, you need, it's like I need this to be in the same path, which kind of sucks. But yeah, we'll see how we can do that. And we also need maybe at this point rotation is 0 and scale is gonna be what? Maybe it's 100 divided by 60. But I don't get it. What's, oh, it wants a vector. So annoying. Vector, and the vector is just that. So I can maybe dot y, and then wait, do we have a easier constructor for vector 2? No. Let's make it, so that's the only, alright, so scaling does work. Okay, so float scale is gonna be cell width divided by texture dot width, but I need to cast at least one to float. Nice. So, you know, it's scaled. I mean, it's ugly, but it's scaled. Okay. Perfect. So that's that. Let me just have here define assets folder list/assets, and maybe something like if not defined, and then I can do something like assets folder. Oops. Fuck. Let me just, you know, do that. And then remove all of these. Delete two words, delete two words. I mean, I can just dot. Okay. So now this should work. Okay, nice. And I can just minus D at any time to change the target directory for the assets. Okay, nice. So what next is looking at moves. So if we double check WASM implementation, we have the moves here. So now it's not going to complain about moves. Whatever. We just need to initialize the moves. Vector 2, and the allocator is no allocator, so we just init. Okay, and then this part, which I don't really care about. Then we have this square to pixel function, which is kind of, you know, square to pixel, kind of useful in a way. Maybe I just want here a vector 2 screen width, screen height, and then we just get that. And now we have square to pixel, vector 2, and do we have a draw circle? Nice, we do have a draw circle. So center x px plus cell width divided by 2, px.y plus cell height divided by 2, cell width divided by 4, and square move. Now square move we already saw. Square move. Now obviously it complains that cell width. Can I just, yeah, I can. but we don't have any moves, so it's not going to do anything. Nice. Just print board, apply move. Well, we'll need apply move. And what's interesting, I think apply move is gonna be same thing for all implementations, right? Like, I don't see why not. Apply move is gonna be the same, bit different, but just let's see. It needs this dynamic array moves, and I think it also needs selected square deselected square. Okay, and now if we go to wasm.c, we don't need this call, we just need to here selected square and move. Right. This px to square function, obviously I kind of want it in Raylib.c as well. So this one should be a vector 2. We already got used to copy pasting this stuff, so okay. So the last thing that we need to do is this part right here, getting the mouse position and all of this stuff. So I'm just gonna add this code and we'll try to make it work. Mouse position, get mouse position, insane. It returns a vector 2. Mouse px, that's perfect. JS hover pixel, pixel to square, that's that. Mouse down is mouse button down. Do we have a left? Mouse left button is selected, so instead of WASM C, we have some extra variables that I want to copy paste. So if it's, and it's the same logic, I mean, again, might be able to refactor this even better into some kind of, you know, not needing to copy paste as much, but I feel like this is the, you know, first step. Oh, it doesn't work. So get mouse position, let's just print f mouse, oh, you know, used to JavaScript, yeah, like Python, sorry, it's float. Anyway, it was a float. So, but I don't see the mouse. Wait, why don't I see the mouse position? Ah, I do see it, okay. But I don't think this is right. Why is it always loading it? You know what, I didn't double check if this thing works. Yeah, it doesn't look like it works. The fuck? I mean, it compiles, but why doesn't it work? Oh my god, I forgot to call insert. Texture and KV. Textures. Right, so now it's not even loading the textures anymore. They are already loaded. Oh. Huh. I mean, it kind of does something, but it's not perfect. So if I have mouse button down, if it's selected is 0, and we do apply move. Dynamic array clear moves. If selected is 1, chess valid moves. Is mouse button down? I want is mouse button pressed, because I want it to be only once. So if I click, it doesn't work. No, it's what? Printf. Yeah, it should work. So I mean, is selected is probably 0, right? No, yeah, it's 0, and then it's 1. Oh, it's something's not good. Something to do with the position of the mouse. I don't think it's right. Let's also see square.file and square.rank, because something's not right with this. So this is 0, 0, 0, 6. The fuck? Why though? This one is fine with 7, 0, but this one is 7, 0, 7, 1. Why is it broken? Maybe I don't need to do this extra -1. Cell height is an integer. This is a float. It's because this thing is a float. It's because my vector was integer, but this vector is a float. Right, so now we get all the valid moves, right? This is pretty cool. Okay, nice. So we were just able to take the WASM C code and just basically copy paste it into Raylib. So we are also able to play the game on Raylib. I mean, it's still it needs some stuff to do, but and if I just run npm run build, it should be fine also on the WASM implementation, so it still works, right? And I think that's pretty nice. So we are able now to play it both on WASM and on native, and I think I want to maybe just to work more on my own to try and make it such that it's like extremely small changes between them, so that we can easily implement at both projects and not have to copy paste too much from one to another. But yeah, I think, you know, pretty cool that we're able to just reuse this entire file for both implementations. So yeah, hopefully this was interesting for you. We're able to play it on native and also on the browser. I think that's pretty cool. Which one do you think looks better? I mean, the scaling is different. Probably they use different scaling methods, but yeah, I mean, it's still pretty cool. So yeah, hopefully this was interesting for you, and we'll see in the next one. So see you.